Hi friends, in this video we will learn about Kruskal's algorithm to find out minimum spanning tree of a connected weighted graph. It uses greedy approach to find optimal solution at every stage. This algorithm is used to find out the subset of edges through which we can traverse every vertex of the graph. So let us consider this graph and we have to find out minimum spanning tree using Kruskal's algorithm using these steps. The first step is remove all the loops and parallel edges from the graph. We have to first check whether a graph contains loops and parallel edges. If so, then we have to remove them. Here, node E contains a loop. Loop means an edge which begins and ends at the same vertex is called as a loop. So we have to remove this loop even though having minimum edge. We have to remove the loop. Then we have to check whether this graph contains a parallel edge. Yes, there is a parallel edge between node C and D, one having weight 3 and another one having weight 5. So we have to remove the parallel edge in such a way that an edge having maximum weight should be removed from the graph and keep the edge which has the minimum weight. So we remove an edge having weight 5 and keep an edge with weight 3 between C and D. After removing parallel edge and loop, the graph will be look like this. Then in step number 2, we have to sort all the edges in ascending order of their weights. For that, we have to first construct a table having edge along with their weights. We have to arrange the edges in ascending order of their weights. So which edge having a minimum weight? Here BC having a minimum weight as 2 and CE having minimum edge as 2. So we specify them in any order. Edge is BC having weight as 2, another edge is CE again having a weight as 2. Then the edge having weight 3. There are the 3 edges having weight 3. The first one is CD, DE, DF and EF. So arrange them according to ascending order of their weights. CD having weight 3, then EF having weight 3, and then the next one is DF having edge weight as a 3. Then next one is 4 between AB having weight 4, then AC, the next one is AC having weight 4, and next is CF having weight 4. Using this chart, we arranged all the edges according to their weights in ascending order. Now, we have to pick the smallest edge to find out minimum spanning tree of this graph. While constructing a spanning tree, you have to mostly prefer to keep the vertices or nodes at the same location. It is not the rule, but it makes construction easy. So here BC, we have to pick the smallest edge. as B, C having the smallest weight as 2. Then next is CE, next edge is C between node C and E having edge as 2. Then next is CD with weight 3, CD having weight 3. And while constructing this spanning tree, we have to continuously check if the spanning tree forms a cycle or not. If there is a cycle while constructing a graph minimum spanning tree, if the graph or minimum spanning tree contains a cycle, then you have to discard that edge. Then EF with distance with weight 3, EF with distance or weight as a 3. Then DF, if we connect DF with edge 3, then it forms a cycle. So if the cycle is formed, if a cycle is formed while constructing a minimum spanning tree, then you have to discard that edge. If the cycle is there, then you have to discard that edge. Then the next is AB with weight 4, AB having weight 4. Then AC with weight 4 as AC. If we join A and C having weight 4, then it again forms a cycle. So we have to remove this cycle. Then AC, then CF. CF, again if we connect C with F with edge 3, with having edge 4, then again it forms a cycle. So we have to remove that edge. It's a final tree. This is a graph, original graph having V number of vertices and E number of edges. Then we have to form a graph as G dash having V dash and E dash, where V dash, G dash indicates the spanning tree. It's a minimum spanning tree using Kruskal's algorithm. So here G dash indicates the minimum spanning tree. V dash is exactly equals to number of vertices which is present in the original graph. So here number of vertices as 1, 2, 3, 4, 5, 6. In the minimum spanning tree, there are also a 6 number of vertices as 1, 2, 3, 4, 5 and 6. Then E dash should be a subset of E. Then the next property is E dash means the edges which is included in minimum spanning tree should be the subset of edges in the original graph. And then next, the number of edges is equals to number of vertices minus 1. As the number of vertices are 6, 1, 2, 3, 4, 5, 6, E dash is equal to the number of vertices are 6 minus 1. So 5 number of edges should be present in a minimum spanning tree. Here 1, 2, 3, 4, 5. It satisfies all the properties of minimum spanning tree. So this is the minimum spanning tree of the given graph using Kruskal's algorithm. So the time complexity of this algorithm is order of E log V, where E indicates edges and V indicates the number of vertices in the given graph. So the total cost of this minimum spanning tree is total number of weights included in this MST. 4 plus 2, 6 plus 3, 9 plus 2, 11 plus 3 is equals to 14. So this is all about Kruskal's algorithm. In next video, we will learn about Prim's algorithm to find out minimum spanning tree.